Good afternoon. For those interested, I thought I'd offer a brief explanation to the earthworks calculations and assumptions made for Argyle Village. I'll start right at the beginning with the existing conditions of the site. As you can see in this drawing, it does show where the existing homes were located. I have traced out the building outlines, and since the foundations have been removed, I have drawn in a 1-to-1 slope coming into the foundation and at varying depths based on roughly what I saw out on site. So to calculate the topsoil stripping, I will go over to my materials tab. And again, this is the whole site with different sectional areas taken off for different depths. But if I go over and click on asphalt removal, for starters, you can see that I've assumed 75 millimeters. The areas highlighted have 75 millimeters of asphalt taken off. For the balance of the site, which is topsoil stripping, anything highlighted in white has been assumed that topsoil will need to be stripped. As you can see, I've removed the buildings and the driveways from these areas, and at this point I'm assuming 10 inches of stripping or 250 millimeters of topsoil. As far as the volume calculation goes, I'll show you that in a bit. Jumping over to the proposed grades, I'm going to hit design and then import the proposed grading plan. Here's our grading plan. As you can see, it's dated July 29th. And basically all the blue lines are traced out lines or snapped from the CAD file of the proposed grading plan. And I will turn on the elevations just so you can see everything that's there. So basically any of the blue elevations mirror what's on the drawing. What I've done is with full basement blocks, I have the grades on the outside of the building established, and then I've also established what the finished basement floor would be, almost to say as if the building was punched into the ground. From a 3D view point of view, this is what the site would look like. Now it can be noted, two of the blocks are slab on grade, Block A and Block F. I'll turn the elevations off just to keep it clean. Blocks B, C, D, and E are full basement blocks. To create a perfect subgrade surface, which basically means I have reduced the amount under sidewalks, underneath the basement floors, whether they're slab on grade, under the driveway areas, parking lots, the single lots, the emergency access road, I've deducted exactly the amount that would be required. So for example, if the slab on grades, I have deducted 150 mils of concrete and 150 mils of granular A to go under that. If I flip over to my materials list real quick, just to give you an example, full basement units, as you can see, there is the depth that I have subtracted from the finished basement floor. If I went to the heavy duty parking area, same thing again. Here's all the depths, and this defines the area that I've assumed. Sidewalks, the single lots, slab on grade units. So what this does is it generates what we'll call a perfect pre-grade, Swiss watch. If we want to look at the perfect pre-grade, this is what it will look like. Now, one thing to note is in the amenity area is a large infiltration gallery. If we need enough earth fill to get it to a rough subgrade surface, I have allowed to excavate this down 1.8 meters below finished. And if I go back to here, infiltration gallery, yep, you can see it right here. And here's what I've assumed within that. For this exercise, we're not building it to the perfect pre-grade. We're going to build it to a rough subgrade surface. No point in building a perfect pre-grade because after servicing, it won't look like it anyways. So what I've done is I've dummied down all of the grades to simplify it to get a rough subgrade surface. As you can see, the green lines denote what everything will be constructed to. In some cases, I've even simplified it and got rid of these little bull noses. I've also broken everything up into areas. So for example, here's the block E area, which will show up on the report. Block F, fringe area 3, block C, emergency access road and rear lot storm area, the singles, I'll find one here for the roads. That's the roads, and block A, of course. To look at the rough subgrade surface, here's basically what will be getting built. Again, a lot less grades than what's shown on the drawing because it's not required at this point. It can be noted that the 2 slab on grade units will be at the same grade as the perfect subgrade surface as an earth grade. Those have to be on correctly now. So to look at this and how much earth will be getting moved, this is a cut fill drawing of the rough grade surface, cut and fill right after the site has been stripped. Red is cut, blue is fill, the darker the color, the deeper. You can notice here, here, over here, and off here over in the distance there's some darker colors. That is where the foundations need to be filled in. And if I give that a hit, you can see it. But that's what the rough subgrade surface will look like when it's completed. Again, the infiltration gallery area to be excavated is only as required. For volumes, going from the rough subgrade surface versus compared to the strip surface, Again, the areas have all been broken out. The amenity area, which is the infiltration gallery area, blocks A to F, the emergency access road, the fringe areas, the lots, the roads, and the totals. When looking at anything, I'd suggest that you look at these three columns over here: cut, fill, and whether each area is a deficit or a surplus. And this part here just shows you the topsoil stripping and removals. Now going from the rough subgrade surface to the perfect pre-grade, this is ultimately what it would look like. Let's go right back down to here again. So again, as I mentioned before, as you can see, slab on grades, no change. Basement excavation for the full basement. The idea is that the builders will dig this out and lose the earth right around here. I don't show the infiltration gallery being backfilled, but again, this gets dug out and then the fill gets displaced around here. And again, the other slab on grade, no change. For the volumes, comparing rough grade to the perfect pre-grade. So the infiltration gallery, this here will not get filled with earth, that will get filled with stone. But if we look at blocks A to F, as you can see, cut, fill, cut, fill, cut, fill, cut, fill. As you can see in the end, there's only 70 cubic meters short. The access road, 75 meters short. The fringe areas, 200. The lots, 90. And the roads, 470. I'm rounding things off. The whole site would be 1,100 cubic meters short, but keeping in mind that I have not factored in anything for pipe bulking, which will probably make up or maybe even turn that into a bit of a surplus in the end. Down here, as you can see, this is basically my assumptions that I took off. This is for the perfect pre-grade. But that is kind of it in a nutshell. So again, hopefully this helps out explaining some of the calculations. The rough grade subgrade surface is basically just a dummied down version to make it simple for now. Thank you.